Well, welcome to Unit 1, the very first video for Algebra 1. What I'd like to do with you is I would like for you to take out your packet because we're going to take our first set of notes in this very first video as well. So on the front of your packet, we're doing video 1010, which is the concept number, and we're doing video A. So there's a second video that goes with this as well. If I turn into my packet, I'm going to see that 1010A is right here. And what are we going to be doing? Well, we're going to be identifying key vocabulary, interpreting a situation, and use arithmetic to determine appropriate solutions, which means we're going to do some problem solving, but we need to focus on using some basic math skills, adding, subtracting, multiplying, and dividing, some other operations as well, to interpret a situation. And to interpret a situation, what that means is we got to figure out what to do. So we need to be aware of vocabulary. Every subject, every job has its own set of vocabulary. So if you're able to learn vocabulary, say in Algebra 1, and apply that, that means there's a really good chance you're going to be able to do that in all your other subjects as well, or any job you might encounter, when you're 20 or when you're even 70 as well. So let's fill you in on some of that vocabulary. Now, some of these items in these first few videos, you probably and hopefully have a little background in. So hopefully a lot of this might be review for you. If not, that's okay, because we're going to take you through the things that you need to be successful. If you have questions when we're done with these videos, you're going to be able to address those in the Teacher Talk too. Let's get started. When we see the word sum, we are talking about the answer to addition. That's what sum means, the answer to addition. The word difference here, when we see the word difference, we're talking about the answer to subtraction. So from those first two words, if we know what sum is and know what difference is, we know what to do. We know what kind of arithmetic to do, and we can interpret a situation and get an answer. Now, product is the answer to multiplication. And since there are four basic operations as far as math goes, we have addition, subtraction, multiplication, quotient then is the answer to division. Now, less than and greater than, they can mean a lot of things, but we need to be aware of the symbol that stands for each. So this is the less than sign, and this is the greater than sign. Now, when we talk about square roots and perfect squares, square roots, that symbol looks like this. Okay. So the square root of a certain number. Well, what does that mean? Or what is, what is the answer to a square root? Well, say we've got something like the square root of 25. Well, the square root of 25 is 5, and I'll tell you why. If we can take 5 times itself and get 25, that's the result of it. So what we're looking for is what a square root is doing is it's asking us to find a value when multiplied by itself gives the number inside here. So we're looking for a value. Now, sometimes these come out to be whole numbers, A lot of times they don't. When we see this word perfect squares and square roots can kind of go hand in hand because we know that 5 times 5 is 25. Well, 25 is actually a perfect square. In fact, let me share with you the first 12 perfect squares that we generally use. The first one is 1. Then 4, 9, 16, 25. Now, let me explain what perfect squares are. You might have figured it out from what we just talked about. 1, 4, 9, 16, 25. Well, 1 is a perfect square because 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. So 6 times 6 is 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. 11 times 11, 121. 12 times 12, 144, and they keep going. Those are pretty common ones that we use. If we took the square root of each of these numbers, it would come out to be a whole number. You'll notice the square root of 25 is 5. And that's true for all of these numbers, that the square root of all the perfect squares has a whole number answer. Now you'll notice this chart up here in the vocabulary, that chart up there is how we round and how we want to round. These are all the places that you'll notice here. Notice when we get to the right of the decimal, the places become tenths, hundredths, and thousands. And one important thing, when we round to dollars, we're rounding to that ones place. Just going to put a little note there. And when we're rounding to cents, that's like rounding to the hundredths place. And you're going to need to be able to do a lot of rounding as we go through this entire course. And we're going to get into that right now. In fact, here's what we have. We have attendance for 2 baseball games as shown below. What was the total attendance for both games to the nearest 1,000? Let's talk about how to round. So to round Monday's attendance, 29,471. We first of all find the thousands place. The thousands place is going to be, and I'll highlight it in yellow, right here. That's where that 9 is. Now, if we look to the right of the thousands place, if that number is 5 or larger, then this 9 or that 29 will move up to the next 1,000. If not, it will round down. So our options are, the answer to this could be 29,000 or 30,000 because 29,471 is in between 29 and 30,000. So it's closer to 29,000. When I rounded the thousands place, notice how I said that, 29,000. To the nearest 1,000, everything matches up with how I said it. The second one for Tuesday, again, we're in the thousands place. So I'll highlight the 3, and we're going to look to the right of it. So our options are, this number is between 23,000 and 24,000. Because the number to the right of the 3 is 5 or larger, this will round up because 23,580 is closer to 24,000 than 23,000. Now it says total. So we're going to take these two and we're going to find the sum of those. 29 plus 24. Now, if you need to use a calculator, by all means you can. But a word of caution, if you're looking at doing higher level math, or you're looking at doing something in the math or science or computer science fields, someday if that's on your radar, you have a great calculator that's built into your head. And you need to use that as much as possible. Because some classes, you're not going to be able to use a calculator in those classes down the road. So use the calculator if you need to, but by all means, it's going to make you better if you can struggle just a little bit or maybe show your work off to the side to get some of those answers. Again, you will realize how beneficial that will be down the road. Okay. Now, some items you're going to need a calculator for because we're going to work with crazy decimals here and there too. So this next item is another rounding question. It says 1.354 inches of rainfall was recorded. Round the amount of rainfall to the nearest tenth of an inch. First of all, we have to figure out where the tenths place is. Now it ends in TH. That's really important. In fact, I'm going to highlight that word right there. And the tenths place is where this 3 is. It's to the right of the decimal point. So I'm going to look to the right of the highlighted place. Since that is a 5, if it's 5 or larger, I'm going to scoot that 3 up to the next number. So this would be 1 4/10. And since it does say inches, I could use the symbol for inches, which is kind of a double quotation mark, or just a quotation mark right there, or I could use the word too. Next, a 7-ounce package of chocolate chips sells for $2.29. What is the cost per ounce to the nearest cent? All right. Well, we want to find the cost per ounce, and how do we want to do it? We want to go to the nearest cent. So we're going to round. We've got some decimals to work with. Now, we're going to talk in the next few concepts about this vocabulary. And so we see this word per, cost per ounce. And what that's really telling us to do is it wants to take the cost and divide it by the number of ounces. So we could write that as 2.29 divided by 7. And so if we put that on a calculator, which I happen to have one right here, if it doesn't have a huge glare on it, we'll get to a point where we can see it a little bit better. Aha. 2.29 divided by 7. And that's what we end up with. I want to round that to the nearest cent. Well, rounding to the nearest cent is the same as rounding to hundreds. So this 2 is the cents place. Now we look to the right of the 2 and we see a 7. So that 2 is going to move up to a 3. So this is going to be 0.33, or we can write that as 0.33, and we can put that in the dollars. So that's 33 cents, or we could write it as 33 cents like that as well. Wrapping things up. We talked above about the symbols, less than and greater than. And let's use them down here. Now, we want you to have a number sense. We want you to be able to look at numbers and say, hey, which is bigger, which is smaller? And sometimes calculators will help you with that, and I'll show you how those can be beneficial. But we got to think of things on a number line. So I'm going to draw a number line off to the side. We're going to kind of do these items in pairs. So here's 0. And as we go to the right on the number line, we're getting larger. And as we go to the left, we're getting smaller. So 5.2. Well, 5.2 would be right here. Put a little dot there. Now, when we compare, we can kind of line numbers up if we want, 5.2 and 5.02. Since the 5s are the same, we look to the next place. We have a 2 and a 0. The 2 is larger than the 0. So that means 5.2 is farther to the right on the number line. That means it's larger. So the sign is always going, the point on the less than, the greater than, is always going to point to the smaller number. Kind of a good way to remember that. So 5.2 is greater than 5.02. Now, when we go the other direction, if both numbers are negative, well, I'm going to kind of draw this out this way. Negative 5.2 is here. But negative 5.02, well, that's a little closer to 0. So negative 5.2 is farther away. That means it's less than negative 5.02. So hopefully you kind of see a pattern if both are positives and both are negatives, how that kind of works. Fractions. Deal a lot with fractions. We like to leave fractions as improper in most cases. Here's 3/5 and 4/5. Well, since the denominators are the same, we look at the 3 and the 4, and we notice that 3 is less than 4, so 3/5 is less than 4/5. Now, speaking of denominators, if we look at this denominator, it's 8, and if we look at this denominator, it's 20. They're different. But sometimes you can think about halves, like, well, what's half of 8? Well, half of 8 is 4/8, isn't it? So if we have 7/8, this is more than halfway. What's half of 20? Half of 20 is 10. Well, 9 is less than 10, so 9 is less than halfway, meaning 7/8 is greater than 9/20. We can also use our trusty calculator as well to answer some of these fractional type items. So let's say that we have 7/8 and we want to change it to a decimal to be able to compare. Well, we can do that one of two ways. We can do 7 divided by 8 to get the decimal, which is 0.875. Might help a little bit. We can also, we have a fraction bar on this calculator too. It's right here. So what we can do is we can go 7, hit the fraction. Notice it puts a little mark in there. Sorry for the glare. And 8, and we can hit equals or enter, and nothing much changed, did it? But on this calculator, there's an F to D key. That means fraction to decimal. So what we're able to do is we can hit, because it's above the button, we can hit second and PRB, or second and fraction to decimal, and hit enter. Change it to a decimal there as well. So that's how you can do some of the fraction things, and more about that coming up. Down here, well, we see the square root of 36 and we want to compare it to 6.4. Well, if you remember that the square root of 36, well, 36 is a perfect square. So the answer to this is really 6. And 6 is less than 6.4. Now, when we get into this, 29/3 and the square root of 53. Well, one thing we can do is we could change 29/3 to a decimal, or we could take 29 and divide it by 3, because that bar means division, and 3 will go into 29 9 times with 2 left over. So this is really 9 2/3. But what about the square root of 53? Well, the square root of 53 is pretty close to 49 and 64. In fact, it's right in between those. And the square root of 49 is 7, and the square root of 64 is 8, so the square root of 53 must be between 7 and 8. Therefore, we know that 29/3 is greater than the square root of 53. Now, to finish this video off, where is the square root key on your calculator? Well, on this particular calculator, it's right above x squared. So what I would do is I would hit second and x squared and type in 53. And you'll notice I get 7.28, which is in between 7 and 8. So what we have is we have completed the first video. And that was a lot of information in this first video. And as we go through each particular concept, some of the videos might be as long as this, some might be quite a bit shorter than this as well. But we'll see you in the next video. Thanks for watching.